In today's session, let we learn about how to implement the Boolean functions using your decoders and multiplexer. So let me first design your Boolean functions which are in standard SOP using your decoders, and then we'll move with your multiplexers. So now the first question which I have given. So here I need to implement a Boolean function of 4 variable using a decoder. Now that 4 variable function is having the input variables as A, B, C, D. So they have given the minterms as 1, 2, 4, 7, 10, 11, 13, 15 are your minterms of this given function whose functional value is logical 1, and the remaining decimal codes which are not present inside the parentheses are having the functional values are 0. In order to design this 4 variable a 4 variable function, we need to prefer a 4:16 decoder. Now as it is 4 inputs, so prefer a 4:16 decoder in addition with a OR gate to obtain your output of your function f of ABCD. F of ABCD is sigma m of 1, 2, 4, 7. So these all the minterms must be added whose functional values are 1, then only we can implement the function f of ABCD. Hence we have to use your one of the OR gate. First, so when you designing your Boolean function using your decoder, first we have to determine or we have to find how many number of variables are there in that given function. So now based on your in given inputs, so you have to take the correct order decoder. So for example, if it is a 3 variable function, then we need to prefer a 3:8 decoder. If it is a 2 variable, 2:4 decoder. So now it is a 4 variable function, hence we prefer a 4:16 decoder. Upon selecting your the order of the decoder, so then we move with your OR gate. So now this OR gate will produce your final output as your function f of ABCD. So is the sum of your all the minterms. So in order to do the summation of these all the minterms, so we are going to use an additional OR gate. So in a decoder, so we learned that each decoder output would generate one of the minterm. So in 4:16 decoder, so this is a 4:16 decoder, so which is having the inputs which are connected with A, B, C, D. Function input variables are connected as your inputs of your 4:16 decoder with an enable input. So and then it will produce the outputs of 16 outputs started with 0 to 15. As our function is sigma m of here, we have given the function which is equal to sigma m of 1, 2, 4, 7, 10, 11, 13, 15. So f is equal to, given function f is equal to sigma m of 1, 2, 4, 7, 10, 11, 13, 15. So each output of your decoder would generate one of the minterm whose functional value is 1. As it is having 16 number of outputs, so we have to connect one of their all the outputs which are there inside the parenthesis to a OR gate input. So hence here we connected the first output terminal of your 4:16 decoder, second output terminal along with fourth output, 7th output and 10th output terminal, 11th output terminal, 13th output terminal and 15th terminal as your inputs of your OR gate. And this OR gate now will give you the summation of all these minterm. So each output of your decoder is a minterm. So hence these all the minterms are added using your OR gates. So and the remaining outputs are left as it is, whose functional values are logical 0. So like this we are going to implement your given function using a suitable decoder. Now another function we have given here, as two functions are given to implement with a 3 by 8 decoder. So as your given function f1 is of ABC variable, 3 variable function, f2 is also with a 3 variable function, and now so the minterms of first function is 2, 5, 6, and the minterms of second function is 1, 3, 4. So now in order to add all these minterms, we require one OR gate. So hence here two functions are given, two OR gates are used, each can implement one of the function, so f1 and f2. So now f1 inputs are transferred or connected from the outputs of your y2, y5 along with y6. So as we have connected here, y2, y5 and y6 are the inputs of your first OR gate which can implement your function f1. Next, f2 will give you the summation of 1, 3, 4. Hence we connected here directly the output of your 3 by 8 decoder y1 as one of the input, and from your third output term of your 3 by 8 decoder along with fourth output of your 3 by 8 decoder is acting like a third input to this second OR gate which can implement your f2. So in this manner, using a decoder circuit, as each decoder output will give you one of the minterm. So hence we are going to construct using here the given Boolean functions only in standard SOP are designed using your a suitable decoder circuit. And we can also implement your standard SOP function using your multiplexers too. So suitable multiplexer to implement this function with the 4 variable. So hence we require a 16:1 multiplexer. So but you can also implement this with a low order multiplexer as 8:1. So both we are going to do now. So first let me try with this 16:1 multiplexer, designing your function f of ABCD, which is sigma m of 2, 3, 4, 5, 8, 9, 12 using 16 by 1 multiplexer, and thereafter we will move to your 8:1 multiplexer. So now, so number of inputs are 4, whereas here in a 16 by 1 multiplexer, number of inputs on your multiplexer is 16, but in order to transfer that 16 inputs through your single output terminal, we require 4 number of selection inputs, and those 4 selection inputs are being connected as the data inputs of your function, which are A, B, C, D. Now S3, S2, S1, S0 are being connected with A, B, C, D. So the most significant bit variable A is connected with S3, B is connected with S2, C is connected with S1, and D is connected with S0. And then here that 16 number of input lines on your multiplexer we are representing with your 0 to 15, and your selection inputs here which are connected with your input functions. S3 is connected with A2, S2 is connected with B, S1 is connected with internally the selection inputs, but when I wanted to implement the function, the given function, you should transfer the most significant bit with your most significant bit of your selection line S3. The least significant is connected to the S0. Thereafter, as here it is given sigma m of 2, 3, 4, 5, 8, 9, 12. Only this minterm functional values are logic 1 and the remaining minterm functional values are logical 0. So here we have 16 number of inputs. Out of this 16 inputs, we need to connect the input 2, 3, 4, 5, 8, 9 along with 12 to the logical 1. So since your inputs, if I transfer with logical 1, then only output become logic 1. So hence here, so these all the inputs 2, 3, 4, 5, 8, 9, 12 of 16 by 1 are connected to the logic 1. The remaining inputs which are not there inside the parentheses are connected to the ground terminal, or it is connected to the logical 0. So based on your input variables combination 0, 0 or 2, 1, 1, 1, so it will give you the functionality which is given with f of ABCD is equal to sigma m of 2, 3, 4, 5, 8, 9, 12. For example, now if I wanted to implement the function, so let I apply. So here for the input combination of 0, 0, 1, 0, if I apply it on here ABCD, that is transferred as selection input. So if 2 is transferred, then I2 is transferred to the output. So where I2 is shorted with the logic 1. So it is connected with logic 1. So hence the data input is transferred through a single output terminal is equal to logic 1. So like this, so whatever the minterms are given inside the parenthesis that you need to consider as the input terminal, and those input terminals are shorted together and connected to the logical one. The numbers or the decimal codes which are not present inside this parenthesis are connected to the logical 0. So which can implement your function of using your function of a 4 variable using 16:1 multiplexer. Next, we can also implement the same function using your 8:1 multiplexer. So here, in order to design this 8:1 multiplexer, so let me take the data inputs in a row wise, D0, D1, D2, D3, D4, D5, D6, D7. We prefer an 8:1 multiplexer, and we are going to write their minterms of 16 minterm, as it is 16 variable function. So 16 minterms are available. So the first row let me write from 0 to 7. The second row let me write from your 8 to 15. So upon writing, so in your given function, so the first row which denotes a bar, the second row denotes your a value. So now if sigma m of 2, 3, 4, 5, 8, 9, 12 are given to implement your function using 8:1. Upon writing this, so let me circle your given minterms. So in your given function, so given minterms are 2, so circle that. So given minterm 3, so they have given fourth minterm, they have given your fifth minterm along with 8, 9, 12. Now if you have, and now we were going to check column wise. If you have a circle, one circle, and this belongs to the row of A, so let me connect the first data input to the most significant variable of your function A. Next, D1 in this column of data input 1. So this ninth minterm is correspond to the row of your A. So hence D1 is also connected with the most significant variable A, where D2 is on your first row which belongs to the A bar. Hence D2 data input of your 8:1 is connected to the A bar. Same manner D3 is connected to the A bar, where D4 column consists two circles. So if I add your this A bar with A bar plus A is equal to logic 1. Hence this D4 is transferred with the logical 1. So D5 is having only one circle on your first row. So hence that data 5 input terminal is connected with A bar, where D6 doesn't have any circles here. So in this column, so hence this output of D6 data input 6 is a logical 0. D7 also doesn't have here any circle, any single circle here on your first row or your second row. Hence that data input of D7 is also connected to the logical 0. Now D0 is connected with A. So now, so we need to connect D0, D1 are connected with the most significant variables, and D2, D3 along with D5, these are connected to the complement of A, which is A bar. And next here D4 is connected with logic 1, so which is nothing but a 5 volts is transferred. And now D6 and D7 are transferred with logical 0, or it is connected with ground. So now next, an 8:1 multiplexer is having 3 number of selection inputs, which are S2, S1, S0. So now the least significant input variables B, C, D are transferred with S0 is transferred with D variable, S1 is transferred with C variable, S2 is transferred with B variable. Now, so upon connecting S2 with B, S naught with a D and S1 with C, it can implement your given function, which is sigma m of 2, 3, 4, 5. So now let I apply here 0, 1, 0. So if I apply 0, 1, 0 on your BCD, so the data input D2 is transferred to the output, where data input D2 is connected with A bar. So since here, so 0, 0, 1, 0, so A value is 0. So A is 0, A bar will be complemented and you obtain a logical 1 output. Now we will verify your D6. So now to transfer your, so here that D6 output value is connected to logical 0. So now on this input variables, let I apply 0 on your A, B, C, D are 1, 1, 0. Since B, C, D are 1, 1, 0, D6 is transferred to the output of your 8 is to 1. So as D6 is connected to ground, so output Y become logical 0. So like this, so your given function is implemented using your 16 is to 1 or your 8 is to 1 multiplexers.